So it looks like on page 25 on the yellow book, they have 1, and then a 10 comes out, a 2, a 13 comes out, a 3, a 16 comes out. So all right. So a couple things that we need to look at. Does everyone feel comfortable that we're adding 3 each time? Okay. So let's, somewhere on this page, let's put a little note. If we add or subtract to get next term, it's going to be called arithmetic. Okay, so if we add or subtract to get to that next lower term, it's going to be called arithmetic. Is that okay? Everyone good? Okay, so this might be something kind of good to have highlighted somewhere on your page where you know where to find it. Okay? Good? All right. So we can answer the second question probably pretty quickly. What is this fourth term going to be? How much? 19? So we just added 3. I like it. Okay, so that's pretty simple to do. Fist of 5 if you guarantee you can get that next term with me. Cool. I like it. All right. So we want to find, yeah. Arithmetic. Yep. All right. So let's figure out our explicit equation. So this is what we kind of have to discover. So remember, we'll start with n. And we'll say this. Okay, if I plug 1 into n, do I get 10 out? No. Okay, so maybe let's just try and make the first term work. I can get that if I, oh, nope. Take it back. Frank, I made a mistake, sorry. All right, if I plug 1 in here, 1 plus 9 is 10. So it works on the first one. If I plug 2 in, 2 plus 9 is 11. It's not the 13. Agree? Okay. So, just got to make sure which page we're on. Where is it? Nope. 24. I was just in this book, it was a different one, so I want to make sure I hit the right term. But thank you. We did nothing wrong. Lesson 3. Lesson 3. Okay. All right. So this doesn't work. So let's keep going. So I think I'm going to take this 3, and what I'm going to do is I'm going to put that 3 out in front of n for right now. Let's see if we can make this work. So that means 3 times n. Yes? Everyone good? So let me ask you this. If I plug 1 in right here, I get 3 times 1, which is 3, and I want it to be 10. So what do I have to add to this to make that very first term? Once I plug a 1 in, 3 times 1, which is 3, what do I have to add to 3 to get it to 10? 7. And I'm curious, maybe this will work. Now, please notice, this 3 here, which is, we called kind of the common difference. It's like whether we add or subtract up. Okay? That kind of, I said I have a 3 here, I have a 3 here. I think that might mean something. Let's see, if I plug this 2 in, if I plug 2 in, I get 3 times 2, which is 6, and 6 plus 7 is 13. Ooh, okay. If I plug 3 in, I get 3 times 3, which is 9. 9 plus 7 is 16. If I plug 4 in, 3 times 4 is 12, plus 7 is 19. So I feel pretty good that this is our explicit function. Okay? And then we want to explain this. Explain. Explanation. So could I say something like last term plus 3? Does that work? Last term, if I add 3 to that, I get here. Last term, if I add 3 to that, I get to that. Add 3 to that, I get to that. Last term plus 3. I think we did something good. And that's number 5. Can I move off this slide? We good? We're happy? All right. So the next one, they tell us they have this. F at n equals 4n plus 1 or plus 6. And then they have 110, 214, blank, blank, and then the 50th term, blank. Oh boy. All right. So it looks like on this, if I go 4 times 1 plus 6, I get 10. If I go 4 times 2, I get 8 plus 6, I get 14. So I wonder what that third term is. If I plug 3 in, 4 times 3 is 12 plus 6. If I want the 50th term, 4 times 50 is 200. Thank you. 200 plus 6 is 206. So our 50th term is that. And so let's see. Plus 4, plus 4. Yes? And then in order to get way out here, it's a whole lot more plus 4s, right? But I don't have to write plus 4 a whole bunch of times. So our recursive function might be last plus 4, something like that. So we're just adding 4 each time as we go through. Okay? If I have, let's see who is paying attention. If I'm just adding 4 or I'm subtracting 4 each time, what kind of equation is it? Geometric or arithmetic? Arithmetic. Okay, so maybe put a little note. This is arithmetic because I'm adding 4. Okay? I'm increasing by 4 each time. Okay, we're good? Like, you guys need a pencil? I got a whole bunch. Happy to give them to you. You guys know what my rule is for pencils. If you borrow a pencil, you have to bring it back to me the day you graduate. Okay. Deal? And you're going to ask, Stirrup, you've been teaching a long time. Has it ever happened? This past year was the very first time it ever happened. I kid you not. One of my seniors at graduation walked up to me with a little nub of a pencil. Mr. Stirrup, here's your pencil. I thought that was pretty cool. Can you hold on for a few minutes and I'll be done, and then when we're at work time? Okay. Cool? Yeah. Had to. All right. All right. Now let's take a look at this number 7, and I guess I didn't ask you to do number 8, did I? But we can work it. Let's see if we can figure this out. All right. Number 7 says the value of the second term is 24. Okay, so let me draw this. So we basically have this. So the first term, the second term that says 24, third term, fourth term. Agree? And they say the second term is 24. They tell us that the equation is this. Okay. So they want us to find the value of the third term. We are on bottom of 24. In the yellow? Does it look like that? Number 7, 8, very bottom of it? Okay, cool. Oh, no, I was just kind of generating what that number 7 said. I'm sorry, I should put number 7. That's for the number. Sorry about that. All right, so this one, they don't want us to fill out the whole graph. I put the grid up just because my mind kind of thinks that. But they want us to find the third term. So what am I going to do with this 3 in order to get this answer down here? What should I do with it? Plug it in? Okay, so if I plug that 3 in, I get this. All right, 2 to the third power is the same thing as 2 times 2 times 2. Agree? All right, ready? Can we do this? 6 times 2, 12. 12 times 2, 24. 24 times 2? Okay. Okay. Oh, but then take a look at this. It said the sequence is being doubled at each step. If I double something, I'm multiplying by 2. And is multiplying by 2 the same as adding or subtracting? If I double something, I multiply by 2. Is that the same thing as adding and subtraction? So they told us everything is doubled, which means I went times 2. Is times 2 the same thing as add or subtract? If I multiply, is that the same thing as add or subtract? No. So it's not arithmetic. Not arithmetic. So because this is being multiplied, this is going to be called geometric. Okay? So that's kind of the term there. And then the recursive function. Spell it right? Recursive. All right. Last times 2. That's kind of what's taking place. The explicit is the actual equation. What am I doing? I'm taking the last term and multiplying by 2. Yeah.
For geometric, is it multiply and divide?
Yes, it is. Yeah. Yeah. Go ahead. And you can always put it on that rail and it'll stay there until tomorrow. All right. All right, so we found the third term. I think we're done with this one. Can I go to number 8? Okay, so the big difference here is we called this geometric. It was not arithmetic because going from here to here, I was multiplying by 2. I was doubling it. Doubling it is not addition. It's multiplication. Addition, subtraction, arithmetic sequence, multiply or divide, geometric. Those are the only 2 types of sequences. Sir? Nope, just yawning. Yeah, just right down. All right, number 8. Number 8 says the third term is 12. It's being doubled. And then the recursive is previous times 2. Okay. Ooh, all right. Yeesh. Okay. Hey, it's being doubled. If it's being doubled, what kind of sequence would it be? Arithmetic or geometric? Doubled. What's doubled back here? So doubled here is also going to be geometric. Okay? All right, so let's figure out the function. They tell us for the third term is this. So if they're being doubled, I'm going to make our little table. So I have the first term, second term, third term. This is 12. If it's being doubled and I go backwards, this is 6, and this is 3, right? So if I double 3, I get to 6. If I double 6, I get to 12. Okay? So let's see. This means it's going to have, let's take a look at the last one. This one, realize I had 6 base of 2 raised to the n. Okay, this one was being doubled, agree? Doubled means times 2, agree? That's a 2 right there. I bet you we're going to have a 2. I bet you we're going to have a 2 raised to some exponent to start. All right, so let's see if we can make this work. Let's see, 2 to the first is 2. I get to 3 here. Okay, hang on. 2 to the first is 2. I get to 3 here. Okay, hang on. Let me try this one. 2 to the second is 4, but I get a 6 here. Let's go 2 to the third, which is 2 times 2 times 2, which is 8. 8 gets to 12 here. So being it looks like I'm adding 2 here, then I get to 4. We have to do it some other way. We have to do it some other way. What do you think? Okay. Ouch. Okay. So hang on. Let's take this. I'm going to take that function. I have 1, 2, 3. And I have 3, 6, 12. Right? And this keeps going. And so far I have this. I have 2 raised to the n. Okay. So let's try and think about how this is going to work. So right now, with what we have here, I'm going to highlight this. What I have right here, if I pull this over to the side, this is actually what I would get. I'd get plug 1 in, I get a 2 out. If I plug 2 in, I get a 4 out. If I plug 3 in, I get a 12 out. Okay, so we have to figure out this 2, this 4, this 12 are not the same as these. Agree? So it looks like if I add 1 to 2, I get to 3. That's great. If I add 2 to 4, I get to 6. Oh, this isn't a 12. That's if I plug 3 in, 2 times 2, that's 8. Huh. Shoot. Where do you want to go with this, friends? What do you think? Let's try something. Let me go 3 times 2 to the n. I just want to see what this does. I'm not sure what this does. I'm just kind of thinking to myself, my first term is a 3. I'm going to put that right there just to see what happens. So if I put a 1 in, 2 to the first is 2. 2 times 3 is 6. 6 is not 3. But let's kind of keep that in mind. Like if I divide it by 2, I can get to 3, right? So let's think divide by 2 for a second. Let's see if that will still apply to this next one. 2 to the second, 2 to the second, that's 4. 4 times 3 is 12. What did I divide the last one by? 2. If I divide 12 by 2, I get 6. Oh, hang on. I'm going to plug 3 in. 2 times 2 times 2, because 2 to the third is 2 times 2 times 2. 2, 4, 8. 8 times 3 is 24. What did I divide by again? 2. If I divide 24 by 2, do I get 12? Uh-oh. Uh-oh. If I divide this by 2, this is my function. All right, now let's think about some of the madness that took place up here. Let's take some of the madness up here. We realized it's geometric because we had to multiply. So there was multiplying that took place between here and here. Okay? It's raised to an exponent because that's the basis of geometric. But then let's see what we can do. All right. My first term, this right here, let's see if we can follow this because we might have a pattern. That's my first term, agree? I have a 3 right there. let's kind of keep that in mind because that might be how we might be able to generate this. And then when we get to the point where it says we double, which is the same thing as times 2 times 2, let's highlight this because this might also be something here. Times 2 times 2. See this 2 right here? I bet you that means something as well. But then how do we get to that divided by 2? And it just is a matter of, at this point, can we maybe think through it? Like, I probably won't have you go divide by 7 or, 16.4 or something crazy. I'll probably just have it just be simple, okay? But that might be a way to walk through that. The explanation, or let's find the 10th term. We want to find the 10th term. So friends, oh boy, I need to plug 10 in. 3 over 2, 2 to the 10th. Stuart, I can't do 2 to the 10th. Yeah. Whoa. Really? I believe you. How'd you get there?
I did the table.
You just kept going to, oh, you expanded that table up, huh? I like that thought. That's cool. So you just kept doubling. You went to 24, then to 48, so on and so forth. Whoa. Whoa. Okay. All right, hang on. Let's make sure we get this right. I totally love your thought. So I got to do it in my head because I'm dumb. I'm sorry. Okay. I believe you. Hold on to your number. Hold on to your number. I want to make sure I can get there, okay? Okay. The way I think of it, and there's nothing wrong with the way you think of it, because I think the way you think of it is beautiful, and I want you to keep thinking that way. But I want to make sure I can, with my dumb way, I want to make sure I can get to your way, which is the smart way. Okay, 2 to the 10th. Ready? Count out. 2 to the 1st. 2, 4, 8, 16. Still with me? 32, 64, 128, 256, 512, 1024. So this is going to be 3 over 2 times 1024. Okay, that wasn't quite your answer, was it? No. So that 1024 is not your answer, right? Okay, I want to try and get to your answer. I think I can. Okay. 2 goes in here. That is 512. And then 3 times that is going to give me 6. 3, 1536.
I know, 1, 4, 5.
I bet you forgot to carry something someplace. But you got close. You got real close. I like that. That's some good thinking right there. You can't make that stuff up. Good job. River, high five to you. The air five. All right. Woo! Holy cow. Huh? No?
No.
You gotta translate both ways for me, kid.
Oh, there, she's like, you get like the anti-rock. It's just so, like, why do you get that? Like, that's
Sorry, I need to explain it.
No, they get it. Like, now they get it.
Okay. Local maestro?
No.
Is that the right way? Is it maestro local?
No. Oh, I know that.
Either way, I love it. All right. Friends, let's move over to page 25. You with me so far? All right. Frank, what time we out here? Because I don't know. Wait, I got it right here. 36? Okay. Here we go. Hey, let's take a look at this page. Let's just take a quick look at this page. So this is page 25. Okay. For these, notice I have two equations up above. Okay, so if you have an F, you plug it into the F1. If you have a G, you plug it in the G1. Okay, and then also down below, all you're doing is you're plugging 1, 2, 3, 4, 5 into that equation, getting the output, and you're plugging 1, 2, 3, 4, 5 into that equation and getting the output. So let's say that page 25. So this is page 25. See if you can complete that, and that'll be kind of the assignment. I'd say if you spend any more than 7 minutes outside of class on this, you spent too much time. Yes, sir. About that.